An accumulative tank farm is one of the most important, and one of the most complex, parts of a refinery. Although it may look like nothing more than a group of storage tanks, it's where hundreds of operational decisions are made every day to keep production running continuously while meeting shipment schedules. In this video, we'll explore how an accumulative tank farm really works and how it's modeled in refinery digital twins. Why isn't it enough for a refinery to simply store products in tanks? Why are some tanks constantly being filled, others waiting for quality certification, and others already being prepared for shipment? In the next 5 minutes, we'll explore how an accumulative tank farm really works, and why it's one of the most challenging systems to simulate in a refinery digital twin. Let's start with where an accumulative tank farm fits into the refinery. Process units continuously produce gasoline, diesel, jet fuel, and other products. These products are transferred to storage tanks, where they wait for quality certification and shipment. From there, they are dispatched by rail, pipeline, marine terminal, or truck. An accumulative tank farm is much more than just storage, it's the buffer that connects continuous production with discrete product deliveries. Every tank in the farm follows its own operating cycle. It starts by receiving product, then waits for laboratory analysis and quality certification. Once approved, the tank becomes available for shipment until it's eventually emptied and ready for the next batch. In reality, the process is constrained by many operational rules. Shipments can't begin before quality certification is complete. Tanks have strict capacity limits. Production targets must be met, while inventory also has to be prepared for future deliveries. This is where most simplified simulation models stop being realistic. The screen shows a digital twin of a refinery process area built with the petroleum refining library. On the left, 2 crude oil sources simulate feed deliveries to the first accumulative pumping tank farm at predefined flow rates. The incoming streams are merged before being transferred to a second tank farm, where the product is accumulated, undergoes passportization, and is prepared for shipment. Now let's see how the first tank farm operates. As crude oil enters the facility, the system automatically selects the most appropriate tank and begins filling it. Once the required volume is reached, the tank becomes available for shipment while the next tank starts filling, ensuring continuous production and uninterrupted product flow. The second tank farm follows the same operating principle, with one important difference. After filling, each tank enters the passportization stage, where the product quality is verified. Only after this process is complete does the product become available for shipment. Now let's explore the model's control capabilities and see how the system responds to changing operating conditions. We'll increase the crude oil flow rates from both sources. As a result, the utilization of the first tank farm begins to rise, and eventually its storage capacity is no longer sufficient to receive the entire incoming flow. The excess crude oil is therefore automatically diverted through the bypass pipeline. Next, we'll pause the simulation and demonstrate dynamic tank reallocation. We'll transfer one tank from the second tank farm to the first. To do this, we remove a reserve tank from the first park and place an available tank in the second park into reserve. After restarting the simulation, the storage capacity of the first tank farm increases while that of the second decreases, allowing the system to handle the incoming flow more efficiently. As the scenario progresses, an additional challenge is introduced. One of the tanks in the first tank farm is taken out of service for maintenance from January 13th to January 20th. To compensate for the temporary loss of storage capacity, we increase the pumping capacity by raising the withdrawal rate. As you can see, the tank farm is now much better able to handle the incoming flow. Next, we investigate how product passportization affects the performance of the entire system. In this scenario, we move the 24-hour passportization process from the second tank farm to the first. The results clearly demonstrate how this operational decision impacts the performance of the entire process. If we wait until the tank is completely filled, it enters the passportization stage. This is exactly how digital twins operate in the oil and gas industry, enabling engineers and operations managers to monitor system behavior, evaluate decisions in real time, and understand their operational impact. You can explore the complete model, including an interactive version that you can run yourself, on our website. Thanks for watching.